derivative of y equals square root of 5x plus 1 all over square root of 5x. And notice that the x is also under the square root. So what we might do on this one, because we're going to be using quotient rule, is we can rewrite it as square root of x, square root of 5, excuse me, square root of x plus 1, and square root of 5, square root of x in the denominator. And so we'll write this as square root of 5, and we'll leave 5 with the radical. It's just a constant, but square root of x I'm going to write as x to the 1/2, because when we go to take derivatives, it'll make our power rule a little bit easier to see. And then square root of 5, x to the 1/2. So that way we don't have to use chain rule, which isn't a problem, but if we would have left it the quantity 5x to the 1/2, we would have needed chain. Not a big deal, just something we need to be aware of, and either way is fine. This is the way that I'm going to look at it for this video. So when we go to do the derivative, we're going to use quotient rule. And first thing we do is we leave the denominator alone. So square root of 5 times x to the 1/2 times the derivative of the numerator. Now again, this is why we did this. The derivative is a little easier to find. It's going to be square root of 5, and then we run our power rule on x to the 1/2. Bring the exponent out front, and then we decrease the exponent by 1. So x to the negative 1/2. The derivative of 1 by itself is just 0. Now minus, now we're going to leave the numerator alone, square root of 5, x to the 1/2, plus 1. And now we're going to do the derivative of the denominator, but it's basically the derivative we just did, because we're doing the derivative of square root of 5 times x to the 1/2. So we know it's square root of 5 times 1/2 times x to the minus 1/2. We'll have some simplifying to do when all is said and done. And then lastly, we got the denominator squared. So square root of 5, x to the 1/2 squared. So now let's start to do some simplifying. So what we should see is when we multiply these two terms together here, a couple things are going to happen. We're going to have square root of 5 times square root of 5. That's 5 times 1/2. So let's write that as 5/2. And then we got x to the 1/2 times x to the minus 1/2. That's basically x to the 1/2 over x to the 1/2, or 1. So this is just going to be 5/2. That's going to happen here. This term here is going to get distributed over these parentheses. When I multiply by this one, I'm going to get the exact same thing I just had, which is this 5/2. Let's put this in parentheses because that's akin to this parenthesis here. Now, when we multiply by 1, we're not going to get any change. We're just going to have the rad 5. Let's put it over 2 x to the minus 1/2. This all over. Now let's just make this easy. Let's square each of these. Square root of 5 squared is 5. X to the 1/2, or square root of x squared, is x. So the denominator right now is just 5x. Now we're going to be able to distribute this negative, and you probably see a little bit of what's going to happen already. 5/2 minus 5/2 minus rad 5 over 2 x to the minus 1/2. Those are going to cancel. We're going to have a negative answer. And so right now, oops, sorry, I forgot to put this over the denominator, all over 5x. So we don't like having fractions in a fraction. This 2 is in the denominator, so I can put it down here. And we also have an x to the 1/2. So let's see, put those in the denominator. And there's going to be a little bit more simplifying to get it to match the answer key. So we got the rad 5 on top. We have 2 times 5 times this x. And then when this goes in the bottom, it's going to be times a square root of x. Now to get it to match the answer key, I'm going to multiply by rad5 over rad5, because that's going to give the negative 5 on top. And then what's going to happen on bottom? I've got a rad5 times 5 and a rad x times x. So basically what we have is 2 times, and what we could do is, let's write it this way. Rad 5 squared is 5. Rad x squared is x, and then we have times rad x times rad 5. And now, because these things have the same base, so for instance, when I multiply square root of x squared times square root of x, those exponents on the x add. So same thing with the 5. So I'm going to get 2 times square root of 5 cubed square root of x cubed. And because those are both under a radical, I can put them under the same radical. So negative 5, 2 square root of 5x, that quantity cubed. So the reason our answer didn't initially look like this is because of the way I took the derivative, versus using the chain rule. But I wanted to show you that you could still get to the answer that was in the answer key on the worksheet.